Welcome to the Core IaaS Resiliency series. My name is Hilary Wang, and I'm a product manager at Microsoft. Today, we'll be diving into how your Azure Compute workloads can be engineered for resiliency in the modern cloud era. We will explore the principles, features, and best practices that keep your critical workloads running, while also equipping you with the capabilities to mitigate impact and recover quickly in the event of a failure. In a world where digital services are the backbone of business, downtime isn't just inconvenient, it's costly. And at worst, it can erode trust and customer confidence. Azure's approach to reliability is about building resiliency into every layer so that your infrastructure and applications remain available, performant, and secure, even in the face of hardware faults, maintenance events, or unexpected demand. Let's start with the fundamentals. When we talk about compute resiliency in Azure, it's important to understand that maintaining high availability, resilient workloads is a shared responsibility. Think of it like a partnership. Azure's responsibility is to provide a rock-solid foundation. We manage the physical data centers and servers to ensure that the platform itself is reliable and secure. Your responsibility is to use the building blocks we provide to architect your application to withstand failure. Even the most reliable platform cannot prevent downtime if an application is only deployed to a single virtual machine in one location. To help you build that architecture, we encourage you to consider the following key principles when designing your workloads. The first is redundancy. This means eliminating single points of failure. In Azure, we allow you to distribute your workloads across multiple fault domains and availability zones. If one component fails, there are other virtual machines ready to take over. Second is isolation. We use constructs like fault domains and availability zones to ensure that failures or maintenance events are contained within a specific segment. This physical separation ensures that an issue in one area doesn't cascade to impact your entire workload. Third is observability and recovery. Resiliency requires the ability to detect issues the moment they happen and act immediately. By monitoring the health of your application and connecting these signals to the platform, you can enable automated recovery, whether that's restarting a stuck instance or recreating an unhealthy VM in a different availability zone. These principles, redundancy, scalability, observability, and recovery, are embedded into Azure's core services. Understanding them is the first step to leveraging the platform effectively. Now, let's take a look at the physical building blocks Azure uses to isolate failures and protect your workloads. At the base level, we have fault domains. Simply put, a fault domain is a group of hardware that shares a common power source and network switch. You can think of this as a single server rack. If a power supply fails or a network switch goes offline, it typically only affects that one fault domain. By spreading your virtual machines across multiple fault domains, you ensure that a hardware failure in one rack doesn't take down your entire application. One level up, we have availability zones. An availability zone is a group of one or more physical data centers clustered together and equipped with independent power, cooling, and networking. Availability zones within a single region are typically separated by several kilometers, but usually stay within a 100-kilometer range. This allows for low-latency communication across zones while still providing enough physical separation to ensure that a local event, like a fire, flood, or power outage, is unlikely to affect more than one zone. Finally, we have Azure regions. A region is a set of data centers located within a specific metropolitan area. Every Azure region that supports availability zones will feature at least 3 separate zones. This structured design ensures that within a single region, you will always have sufficient infrastructure redundancy to distribute your workloads and run high availability applications. So, how do you put these building blocks to work? When it comes to compute workloads, there are 3 main deployment strategies. Choosing the right one depends entirely on your workload's specific resiliency goals and capacity requirements. Strategy 1 is a regional deployment. With this approach, Azure can place your VMs anywhere within the region, giving you access to the widest pool of available capacity. This flexibility maximizes your deployment success rate. For virtual machine scale sets, you also get protection against rack-level failures as Azure spreads your VMs across multiple fault domains within the region. However, the main trade-off in a regional deployment is that your compute and storage components are not guaranteed to be placed within the same zone. For example, with a regional VM, your compute may be provisioned in Zone 1, while your OS and data disks are provisioned in Zone 2. If either zone has an issue, your VM is impacted. This means that regional deployments are not guaranteed to be resilient to a zone outage. Strategy 2 is a zonal deployment. This is where you explicitly pin your virtual machine or virtual machine scale sets to a specific zone, say Zone 1. The benefit of zonal deployments is that your compute and storage components are guaranteed to live within the same zone. This eliminates cross-zone dependency risk found in regional deployments. However, because your components are only deployed to a single zone, you are effectively putting all your eggs in one basket. The risk here is that if Zone 1 itself experiences an outage, such as a natural disaster or major infrastructure failure in the data center, your resources will be impacted. Therefore, a single zone deployment is also not guaranteed to be resilient to a zone outage. Finally, strategy 3 is a zone-spanning deployment. This is the gold standard for compute resiliency. Here, you would use a virtual machine scale set to distribute your instances across multiple availability zones, for example, zones 1, 2, and 3. The benefit in a zone-spanning deployment is that each individual VM is zonally aligned, meaning its compute and storage components are guaranteed to be located within the same zone. But the VMs in your overall scale set will be distributed across the selected zones. This strategy maximizes your resiliency to zonal outages to ensure that even if one zone goes offline, the rest of your fleet remains available to handle traffic in the remaining zones. Now that we've covered the 3 deployment strategies, let's talk about best practices, starting with single-instance virtual machines. Single-instance VMs are often the first step for customers moving to the cloud, whether it's for lift and shift migrations, development environments, or workloads that don't require horizontal scaling. While they don't offer the same level of built-in redundancy as scale sets, here are several best practices you can follow to maximize your resiliency. Whenever possible, deploy your critical VMs to a specific availability zone. This ensures that your VM, its disks, and associated networking resources are all co-located within the single zone, eliminating cross-zone dependencies and improving both resiliency and performance. If your application is truly mission-critical, don't rely on a single VM. Deploy redundant instances across multiple availability zones and replicate your data appropriately. This way, if one zone experiences an outage, you can have a standby ready in another. And if you have existing regional VMs that you'd like to make zonal, Azure provides tools to help. Azure Resource Mover can migrate single-instance regional VMs into zonal configurations, giving you improved resiliency without having to rebuild from scratch. Beyond deployment strategies, it's important to understand that stateless and stateful workloads require fundamentally different approaches to resiliency. The right design depends on your cost considerations, how much blast radius protection you need, and your recovery objectives. For stateless workloads, resiliency focuses on minimizing downtime rather than preserving data. Regional protection can be achieved through active-active or active-passive deployments using virtual machines or scale sets with auto-heal capabilities. If you need coverage across 2 regions, such as East US and West Europe, you must deploy separate instances in each region and use Azure Global Load Balancer or Traffic Manager for routing. For zonal protection, Azure provides built-in capability through virtual machine scale sets to span multiple zones seamlessly. You can also achieve similar protection by deploying individual VMs across different zones, though you'll need to manage each instance separately. For stateful workloads, data replication is critical to maintain integrity and minimize data loss. For regional resiliency, Azure Site Recovery enables failover to another region with a recovery time of minutes and a recovery point of seconds. At the zonal level, zone-redundant storage disks offer 0 data loss and a recovery time of minutes, ensuring your data stays protected during a failover. Backup solutions provide an additional layer of protection for longer-term recovery scenarios. Regardless of your architecture, we recommend that you regularly test your recovery process. Tools like Chaos Studios and Azure Site Recovery's test failovers allow you to simulate failures and ensure that your workloads are prepared to handle a real outage. For workloads that require more than one VM, virtual machine skill sets are the natural next step. Skill sets allow you to deploy and manage a group of virtual machines as a single logical unit, handling the complexity of placement and coordination across your VMs. Let's explore some key skill set features designed to maximize the resiliency of your workloads. First, let's look at application health monitoring. By default, Azure monitors the underlying hardware and ensures that your virtual machines are running. However, it doesn't intuitively know if the application you're running inside that VM is responsive. By using Application Health Extension or Load Balancer health probes, you can provide precise application-level signals to the platform. This allows the platform to perform safe updates, rebalance capacity, and trigger automated recovery, ensuring that the platform actions are always guided by the state of your applications. For example, with instance repairs, if your application reports an unhealthy status, the skill set can automatically detect the issue, terminate the unhealthy instance, and deploy a fresh replacement. This allows your system to self-heal from application-level failures automatically. Next, let's talk about automatic zone balance, currently in preview. For zone-spanning deployments, your resiliency relies on having instances evenly distributed across zones. However, scaling actions or capacity constraints can sometimes leave your skill sets unbalanced, perhaps with too many VMs in Zone 1 and not enough in Zones 2 and 3. This feature actively monitors your skill set's zone distribution. If an imbalance is detected, the skill set will automatically redistribute instances across the selected zones, helping your workload maintain an optimal resiliency posture. Third is capacity. We mentioned earlier that pinning to zones can sometimes limit your capacity options compared to regional deployments. To solve this, VMSS Flexible Orchestration offers a feature called Instance Mix. This allows you to specify up to 5 different VM sizes within the same skill set. By providing a broader list of acceptable options, like specifying both AMD and Intel sizes of a VM, you can significantly increase your deployment success rate. Azure can deploy a mix of these sizes simultaneously within the same skill set, allowing different VM SKUs to run side by side. This ensures you get the compute power you need, even in constrained environments. Finally, what if you already have a regional skill set today and would like to become zone spanning? You can simply update the zones property on your existing skill set to include a list of availability zones. From that point on, all new instances created during a scale-out will be zonal. This creates a natural migration path. As your skill set expands, new zonal instances are added. And when you scale in, we prioritize removing the regional instances first. This allows your fleet to progressively transform from a regional deployment to fully zone spanning, all without downtime. Now, let's see these features in action. Here, we're creating a new virtual machine skill set in the Azure portal. Notice that we have selected 3 zones to create a zone spanning skill set, and we are selecting multiple VM sizes through Instance Mix. We will also be enabling automatic zone balance to keep our instances evenly distributed. Once deployed, we can see that our skill set has 9 instances. They're currently balanced with 3 VMs each in zones 1, 2, and 3. Now let's simulate an imbalance. We'll manually delete all 3 instances in zone 3. This leaves us now with an uneven distribution of 3 VMs in zone 1, 3 VMs in zone 2, and 0 VMs in zone 3. We'll step away for a moment and let the platform work in the background. Keep in mind that automatic zone balance is designed to gradually rebalance your skill set to a more resilient state. Only one VM is moved at a time with back-off periods to minimize churn on your workload. Now we're back. Let's take a look at activity log to see what happened. we can see that automatic zone balance detected the zonal imbalance and triggered 2 rebalancing operations. By clicking into the operation, we can see the new VM that was created and the original VM that was removed. With the 2 operations, automatic zone balance removed 1 instance each from zone 1 and zone 2 and recreated them in zone 3. Here we can see that our scale set is now balanced, with 2 instances per zone. Without any manual intervention, the platform was able to automatically detect and restore the scale set back to a zone-resilient posture. In today's session, we covered the foundational building blocks of fault domains and availability zones, the core deployment strategies, and active resiliency features of Azure Compute. To summarize, here is the core framework for building resilient compute workloads on Azure. First, prioritize isolation. Whenever possible, use zone-spanning deployments to physically distribute your instances across availability zones for maximum protection. If zone-spanning deployments are not possible for your workloads, ensure that you are distributed across 3 or 5 fault domains to maximize rack-level isolation. Second, for any workloads running more than one virtual machine, consider using virtual machine scale sets to simplify your orchestration. This unlocks automated distribution, capacity management, and batch operations at no additional cost. Third, enable active resiliency capabilities. Use features like application health monitoring, instance repairs, instance mix, and automatic zone balance to monitor, repair, and balance your fleet automatically. And finally, if you are running on regional deployments today, consider migration paths like using the zones parameter to progressively transform your fleet to a zone-spanning architecture without downtime. Resiliency by design means building reliability into every layer of your compute architecture. By leveraging Azure's built-in features, best practices, and automation, you can deliver uninterrupted service, innovate confidently, and meet the demands of the AI era. Thank you for joining this session.